Okay, so for this first question, we've got this curve. It's going to look something like this. The gradient of that curve at every single point is going to look different. We need to find firstly an expression for the derivative. So in part A, we're going to have dy dx. So we take the 2, we drop it to the front, we get 2x. On this one, it's a linear term, so the constant is the derivative. This is the derivative. Take care with a question like this not to mix it up with the integration. At this point on calculus, it's very common for students to do a bit of differentiation, a bit of integration in the same question, confusing the two. What does the derivative tell us? The derivative is a special function that will tell you the gradient of the function at any point. So it will tell you the gradient of the tangent line. So this curve, let's say we're trying to find a tangent line here where x is equal to 1. So the derivative will give us that. So in B, we start by finding the gradient of the tangent. I'll just call that t. We do that by putting the x value here into the derivative. The x value is given there in the question. So finding a tangent line or finding a perpendicular line guaranteed is on your major. Guaranteed. You're going to find a tangent line, or this is a variant of the question. This is a variant of the question, but you'll find a tangent line or a normal line. Put it in, we get 2 minus 4. So this is negative 2. This tells us that the gradient of the perpendicular is the negative reciprocal of that. So in this case, it's going to be a half. This is the gradient of the line that we're trying to find. We're trying to find the normal, which is the perpendicular to the curve at the point where x is equal to 1. Now, x equal to 1 isn't a point. A point has an x value and a y value. How do we find the y value? Well, we've got a function here that will tell you the y value at any point. One of the things people struggle is, do I put x into the function or into the derivative? In this question, you have to understand you need to put it into both. And one of them tells you the gradient, or helps you find the gradient, the other one tells you the y points. So if we put that into the function there as well, so we want to find next y of 1. So we take y of 1, we get 1 squared minus 4 times 1 plus 2. So that's going to be 3 minus 4, so negative 1. So this is telling us now that the point that it goes through is 1 comma negative 1. And at that point, the slope of the normal is a half. So we've got all the information we need now to create a line. And to create a line, we use point slope form. So if we take y minus y1, it'll give us y plus 1. We take the slope, which is a half. We take the x value and we put it in there. And this is point slope form or point gradient form of a straight line. We've seen this a few times. So now what we need to do is we need to give it in the form in general form. So we see this equation, it's in general form. General form is ax plus by plus c equals 0. The a, b, and c have to be whole numbers. So the easiest way to create whole numbers is here at this point, we have a 2 there. We've got to get rid of that 2 in the denominator. So if we multiply through by 2, we can get 2y plus 2 is equal to 1 times x and 1 times negative 1. So that simplifies to that. Move everything across, and I'm looking here. Look at this. This is where I'm heading. So I need to subtract x from both sides. I get 2y minus x, and then I can add 1 to both sides. Plus 3 equals 0. And then I'll end the question, because this question says, show that the normal is this. So it's giving you the answer, but it wants to see the working that will get you to the answer. The normal question won't give you the answer. This is a sign variant on it. That's why it's question 1 on this paper, because by giving you the answer, it makes it slightly easier. Normally the question will say, find the normal, find at this point. And then it's slightly harder. No, I'm going to just...
I'll take a picture of it.
You can, but I'm recording this. I'm recording everything I say, and then I'm going to upload my working as well. So if you just want to watch, you can. You don't necessarily have to copy down my work. So our next question, the following diagram. So your exam is going to have an easy tangent line type question and an easy find the area question. This is the easy find the area question. So we have this diagram shows part of this graph. So we can see that this is going to be a quadratic curve. We can see the curve here. And our first thing to do is write down the region of R. So in order to do that, looking at the diagram, we need to find this point. You can see that you can put this into your graphing calculator as it is, graph it and find it. But you can also see it. So what x value makes this 0? This one is -4. So -4 plus 4 will make it 0. This one's -4. This one here, if we put x equal to 2 in, we'll get 6 minus 2, and that will be 0. So this is x equals 2. So from factor form, you can see immediately what the roots are. But if you don't know that, you can just enter the graph into your calculator, or you can enter it into AISL and set it equal to 0. That will tell you the answer. You can enter it into the graphing calculator. That will tell you the answer. The reason I use this technique is it's quick, and it's all about speed. So the better you understand things, the less you'll run out of time. We need to write the integral for the area. So you're going to have to, let me get a physical copy of the paper so I can still see the question when I scroll down. So for this one, notice don't answer here on this paper. It doesn't get marked when you write here. You have to answer on this next paper there. When you answer on this paper, make sure you tell the examiner, at this point it's me, what question you're answering. So the first question is to find the integral. So integral symbol, we're going to go from 0 to 2. We just work that out. That will be the first of these 2 points. And then just forming the correct kind of integral. We don't have to expand the bracket. We can put 6 minus 3x, close bracket, open bracket, 4 plus x, dx. No. 6 minus 3x, 4 plus x. Dx. So then we write that. That's question A. B is we have to find the area of that. So we can use our graphing calculator for this. And I'll pull up my graphing calculator here. And here on the graphing, I'll just refresh it a little bit. One of the best things to do is to press on, say new. It's a new exam, so I don't want anything from my previous work there. I'll put this up. So I have to type this into the calculator. I press menu, calculus, numerical integral, 0, up, 2, I go down, bracket, 6 minus 3x, close bracket, multiply. I always like to put a multiply in when I'm working on the calculator, particularly on AISL, it likes it. So sometimes it gets the answer wrong if you don't. So put that in, scroll across a couple of times and put an x. Check that this is the same that's written there. Yeah, it looks good. 28 is the answer. So this is equal to 28 area units. I read question B again, find the area. I've done it. Just verifying. So question C, we're given this diagram. We scroll up on the video to show the diagram again. We're asked to find the area of this triangle. So the area of this triangle can be given by half base times height, and we've got the height here. So this would be the height. And the coordinates there is 3, 10. So this length has to equal 10. The length of the base is this direction here. Now it goes from 0 up to A. So the length of that lane is A minus 0, which is A. So I've got 10 and A. So in this question, I have to find the value of A so that that triangle has the same area that what I've just calculated. That's what it says. It says, find the value of A so that the x-coordinate of C such the area of the triangle is equal to the area of the region. So 28 this has to equal. I've got 10 in there. So for C, I say that 28 is equal to a half times the base times the height, which is this. Simplifying that, half will give me 5a is equal to 28. A is equal to 28 over 5. This is the answer. So at this point, I reread the question a little bit, just make sure I've answered it. So I've got an answer. Oh, a good habit when you get an answer, just check the question again and say, have I answered what it asks? Find the value of A so that the area is equal. Yeah, I've done that. There isn't something else I was to do next. Let's move on to the next one. Ooh, that's way too many words. Inspectors are investigating carbon dioxide emissions of a power plant. Let R be the rate of in tons per hour which the carbon dioxide is being emitted, and T being. So an important keyword here is that capital R is a rate. When you see the word rate, rate of change or rate of this or just rate, that's a derivative. Derivatives mean rate, rate at which something happens, rate of change. If it's looking for a rate of change, it's looking for the derivative. Here it's giving me a derivative. So I'm pretty certain I'm going to be integrating. So rate of 8, and also you can spot a derivative because it has typically it will have a compound unit. It has the unit tons per hour, per. So this is 1 unit per 1 other unit. That's a rate of change. That's a derivative. Derivative is y divided by x. So the y value is in tons. I've not even read the rest of the sentence. The y value is in tons. The x value is in hours. I can see this there at that point as well. At which carbon dioxide is being emitted, and T is the time in hours since it was inspected. So you can see that, it tells you there in the question. When R is plotted against T, the total amount of carbon dioxide is represented by the area. So another keyword, I knew that was going to be area by this word, total amount. Integration is a summation. That's why it has the big S looking symbol, because it's adding things up as you move across. It's adding up areas. So when you're totaling up, when you're adding together y values, you're summing them up. That's often produced by an integral. So linking these can help you with your understanding. So we need to find the area under the curve on this one, basically. R is measured over the course of 2 hours, and we have a little table there that shows it. So at this point, you don't have a function. There's only one way to find it. You're going to be using the trapezoidal rule. The question being very nice at this point is saying, use the trapezoidal rule with an interval of 0.4 to estimate the amount of the carbon dioxide under the 2 hours. So it tells me that my H in the trapezoidal rule is going to be 0.4, but I also see it here in the table. These are all 0.4. So we just need to use the trapezoidal to estimate. So it's a trapezoidal rule one. Put your A here at the side. Let's have a capital A for area. Grab your formula sheet, or pretend to grab your formula sheet, and because you've memorized it after 30 years. So we have a half times this value, 0.4. Then inside the bracket, remember with the trapezoidal rule, so one trapezoidal rule will have the sides 30 and 50. The next will have the sides 50 and 60. The next will have the sides 60 and 40. And the last will have the sides 20 and 50. We only use the 30 and the 50 once, because the end points only use them, but all the middle ones get used twice. So this is going to be 30 plus 50 plus 2 times. And then these ones, we need 50 plus 60 plus 40 plus 20, close bracket, close bracket. This problem, what you'll get wrong here is you'll lose a bracket. You'll not put in enough brackets in the right places. Or the other common one is inside that bracket there, you'll put 30 and 50 as well. I saw one student do this yesterday. They did 30, 50, 2 times 30 plus 50, and they'd have the 30 and the 50 in both places. And that's common mistakes. So putting this into your calculator, if you want to calculate, or you can just, that one's pretty easy. You can do it by hand in your head. And we can see that's going to add up to 84. So this gives us 84. What is the unit? What is the unit of the R value here? The R value has the unit tons per hour. So the integral has the unit tons. So this is going to be tons. Okay, so our next question B is the real amount of carbon dioxide emitted during these 2 hours was 72 tons. We need the percentage error formula. So if you get your formula sheet again, on topic 1, percentage error, it's the actual value minus the estimated value over the actual value. And then we need to have a positive value there. So on the formula sheet, it calls it the exact value and the approximate value. So on using the formula sheet, your percentage error is going to be, we use the absolute function and we use the estimated value, 84 minus 72 over 72 times 100%. Whenever you have a formula, like the first part in A and the first part in B, always put the formula up with the values in, because that's usually your first point. If things go pear-shaped from that point, you can often get the method point for just doing it in the right way anyway. Putting that into your calculator, we can see it to 3 significant figures. This is 16.7%. Have a look at the next question. So we're halfway through. The rate of change of the height of a ball above the ground is measured in meters, t seconds after, the rate of change of height of a ball above the ground is measured in meters, t seconds after it's been thrown until it hits the ground, can be modeled by derivative. Okay. The height of the ball is, when t equals 0, is 1.2. So this is an integral question, like it's a definite integral. It's an indefinite integral question where we find the c value. So we're given a derivative, and we need to find an expression for the height. So we're given dh dt. We need to find h. So h is equal to the integral of dh dt, which is 11.4 minus 9.8 t with respect to time. If we integrate this one, we're going to get the value 11.4 t minus 4.9 t squared plus c. What we need to do next is an expression for the height. We don't have the c value yet, so we can find the c value using this point here. We know that it goes through 0, 1.2. That's a coordinate. So putting these in, we get 1.2 is equal to 11.4 t minus 4.9 t squared. Sorry, I need to put my t's in. Our t value is 0. Ooh, nice. Let's put those in. Plus c, which is easy. It means that c is 1.2. C is 1.2. So I can see here from the information I've got in the question, it looks like this. So you're stood here at a height of 1.2, not very high, or maybe that sounds about the height of a person holding a ball. That's the height, 1.2 meters, is about here on me. So that's the height that you're holding it at. You're throwing it up like this one because it goes up, and then it comes down like that, and then it'll hit the ground. So I think this is a person at 1.2. That's not their height, it's their height up to about their arms or whatever. So we throw the ball, we get this. We haven't finished that last question because it asks for an expression. I'm going to give it as a function. H of t is equal to 1.14t minus 4.9t squared plus 1.2. What are we doing next? We need to find the value of t at which the ball hits the ground. So what is the height when the ball hits the ground? 0. So what has to equal 0? The y value. Well, so this function. So we can say that 0 is equal to 11.4t minus 4.9t squared plus 1.2t. The best way to solve this one, the quickest way to solve this one, is using the polynomial root solver. You can graph it and find it, and it's nice to see the picture. But you can use a variety of different tools. One of the good ones is this one, menu, algebra, polynomial tools, find the roots of a polynomial. It's a second degree polynomial. The first term is, the lead term is minus 4.9, minus 4.9. The next term is 11.4, and then the last term is 1.2. When we enter that in, you can see the function there, looks how it's going to look, and it will give us two values. The good thing about this one is it will give you all of the solutions. NSolve would only give you one. So putting that into NSolve, it's going to give you this one, minus 0.102, whereas the polynomial root solver is going to give you both, and we instantly get to both. So the answer here is t is equal to 2.4. I'm in 3 decimal places here, so I'll just change that. Document 7.2, and then change this to float 3. Press enter again, and then it's giving me to the right number of significant figures, 2.43. Let me just show you how you can solve that on NSolve. Let me show you how you can solve that on NSolve and fix the problem.
So if you do it like that, it's always the positive answer.
That makes sense when you're talking about time. So time moves forward from 0. Time moves forward from 0 upwards. It doesn't go backwards.
So if it wasn't,
but you have to understand from the context of the question.
Yeah.
But let's say let me just digress for a second and say we were going to use NSolve, which is our go-to thing for everything. And we type in 0 is equal to 11.4 x minus 4.9 x squared plus 1.2 comma x. It's going to give us one answer. It's the wrong answer. So you press up on your calculator twice and you press enter, it drops it down. Move inside the bracket, we can say comma, 0, comma. I'm going to give it a second bound. Let's say it's somewhere between 0 and 100, and it gives us the next one. If you keep doing this with NSolve, taking the previous answer as your lower bound, so our lower bound was at 2.43, so I'll just go 2.44, and I'll keep going to 100. When there are no more answers to be found, it gives you this message. So just keep taking your answer from NSolve, having it as your lower bound, having a larger upper bound. Just keep putting it in until you find all of the solutions that you need, depending on your question. Useful for trigonometric equation solving. So that's B. Let me just check B. Find the value of t at which the ball hits the ground. Was that this one in seconds, or it must be seconds? Yeah. This one's in seconds. C. So in C, we wish to write down the domain of h. So it's not sensible for a function of time to allow anything less than 0. 0 is allowed in time functions because this is its initial starting point. It even says it in the question that it is at 1.2 at the starting point. So we'll include that. It can hit the ground, no problems, that's 2.43. After that, the model won't work because it's not going to keep going down. The model is a quadratic which keeps going down. When you hit the ground, it's going to come up again. So this model is no good beyond that point. D, find the range of h. So we might want to graph it at this point. So we'll press control, add a page, add a graph. We type our function in. It doesn't matter which order we're doing. So I'll do this one, 11.4 x minus 4.9 x squared plus 1.2, enter. We see the graph, we see how it looks a little bit. We need to see this top bit. It's a little bit higher than 6 or 7. So I'll just adjust my window with menu, window settings. We've said that the domain goes from 0 to 2.43. And the x value, obviously, it can't go below the ground. And the upper value, I'm just going to put in something a bit bigger. I'll call it 12. It's going to be less than that. We see the function look a little better now. So what we want to do now is we want to analyze the graph and find the maximum we can see here that the maximum is going to occur at 1.16 seconds, and it's going to be a height of 7.83. So when we're asked to find the range of h, here in D, obviously it can go from 0, which is on the ground, and it can go up to a maximum height, and that will be included, 7.83. So here's the range.
So you want me to fill that out for you?
Sorry?
You want me to fill that out for you?
No, good. Thank you.
Check her out this one.
I know, right? It's good. There's a lot of COVID around at the moment.
Oh, yeah. Okay, I'll fill it out outside.
I'm good. But thank you.
Of course.
And what is this? Please, or someone else's book?
You can barely do it yourself, how are we supposed to do it?
I can do it any other day than the night after you come back to school night.
Oh, yeah.
Did you meet my mom yesterday?
Yeah, that's why.
I was like, why does he still at school?
Yeah.
Sir, did you meet my mom yesterday?
Your mom came?
No,
She did.
I've met her before though.
Yesterday, no.
I didn't meet her
yesterday.
I don't remember. I don't remember meeting her.
Maybe my mom did like, she said she went to all my classes.
Well, then maybe she could have easily done that.
It was like a full thing, maybe you just didn't realize.
We were one of the last ones as well,
Yeah.
because of where we are on the schedule. So at that point, I was stupid.
You must have been tired as well.
Yep. A company produces and sells electric cars. The company's profit P in thousands of dollars. Changes based on the number of cars X they produce each month. So this is the marginal profit function. The rate of change of their profit of producing X cars is modeled by this. So X is the number of units they're making. This topic is marginal profit. The company makes a profit of $260,000 for every 15 cars they do. Take care with questions like this one, where the Y value is in $1,000. So you use your Y values at 260 in these types of questions, whether it's in thousand or million. And then when you interpret, you have to add 1,000, the extra zeros in. So take care with this. This is very common for these type of problems to have this type of a unit sort of transfer in it. So we need to find the expression of P in terms of X. We're given, so the question is fairly straightforward. Find P in terms of X. And here you've got dP dx. So you've got a derivative very clearly. You can see it's very clearly marked as a derivative, and you have to find the profit. So this function is marginal profit. We have to find the profit function. So the profit function, make sure you say which one I'm doing. I'm doing that one. The profit function is the integral of minus 1.6x plus 4.8 with respect to x. That's going to give me minus no. Let me not simplify it too quickly.
So,
Yes.
are all these formulas, like the trapezoidal one as well, are all these in the booklet?
Yeah, they're all in the formula.
So there's nothing we need to remember, like.
No, but it can speed you up.
Yeah, of course.
It can. So, for instance, for the power rule, I would expect you to know that one because it will speed you up. So we have minus 1.6 x squared over 2 plus 4.8 x plus c. I would simplify your fractions. You can do 1.6x over 2 on the calculator if you want, or you can just say this is minus 0.8x squared plus 48x plus c. Next, we have to enter our point. So the company makes 260,000 for every 15. So 260 is the profit. Profit is the Y value in our case. So we put 260 here. And then minus 0.8 bracket 15 squared plus 48 bracket 15 plus C. So carefully put your X and your Y values in. This function is designed to use 260, not 260, 000, but you interpret that in your answers. So I'll do this one on the calculator for you, just show me doing it. We will end solve it. So So menu, algebra, and solve, type your equation in, 260 equals minus 0.8 bracket 15 close bracket squared plus 48 open bracket 15 close bracket plus C, comma C, enter. We get one value there at minus 280. So that makes sense. If we were to make no units, how much profit would we make?
Oh, no, negative.
Negative.
Because
Because
you
you're losing
spend
the
money,
fixed
yeah.
or not.
Yeah, because you have fixed costs.
Yeah.
So when you're talking about profit, you're going to be at a loss before you even start. Because you have expenses, so you're going to make a loss of 280,000, whatever the currency unit was, dollars.
So what is negative? It's always a loss, right?
It's always a loss.
And then a positive profit. Makes sense.
For profit, in terms of profit. So we've got minus 280. So this means we need to find the profit function, P of x is equal to minus 0.8 x squared plus 48x minus 200, was it 60? Not that one. 80, 280. Here is our profit function. Reread the question, find an expression for P in terms of x. I'm done. B. Notice me pretty much using every line here. I'm not leaving a gap every line because I need to use the whole space carefully. I use an extra line there because I got that fraction and I want to be able to read things, but use your space and plan the use of your box carefully.
So
If necessary, put a line down and section off this box if you run out of space, just so that the examiner can follow your line of logic through the page.
if you somehow manage to go like outside the box, it's still fine.
If you just scroll over the sides, that's fine. Yeah.
And if you even go like underneath.
Yeah, but don't do it on one of those questions where you have the box and the different. That question back. So this question here, don't do the answers just up here because they don't tend to look there. You need to have everything you need there. You can use it for your scrap working. That's fine because they don't allow scrap paper in the IB. But
It's not allowed.
no scrap paper.
So you kind of just show your, I mean,
What if I need extra space?
yeah.
Ask for an extra paper, use it, and then cross everything out when you're done, and then you hand it in.
You have to handle it.
You have to hand it in. They have to. So they take everything in. So basically, the idea about the scrap paper is they will collect it as the actual working. So the examiner doesn't get confused, but they'll tell you at the end of the exam if they read the script correctly. And I think Dr. Widolia Welch follows the rules like that. No? It says anything you don't want to be assessed, put a line through it.
So you know Dr. Widolia, or where's your Miss Widolia? Do you know she speaks Swedish as well?
I do.
She
She's
speaks
She's like 5
It was really
languages.
weird. Like I was so confused.
Yeah, she did a year from her university reading in Sweden.
And she learned Swedish.
Yeah.
One
Yeah,
year.
1 year, and it's good as well.
And yeah, it's better than her English.
No, like,
That's crazy.
wait, where's she from?
France.
France.
Oh.
She knows like 6 languages.
Yeah.
That's okay.
Okay. All right. B. The company regularly increases the number of cars it produces. Describe how their profit changes if they increase production to over 30 cars per month and up to 50 cars per month. All right. So this question is getting harder now because you have to interpret meaning. There'll be a couple of questions, usually on the paper, a couple of parts at the end of one, where you have to make interpretations. And this is where it gets trickier. So what happens then is we need to sort of find some values. So let's find out how much profit is made when we make 30 cars. That's a good start. So I'm going to use the profit function for this one and put in 30. So to use the profit function quickly and easily on the calculator, I'll just go over to my graphing screen here. I will press tab. It will flash around all over the place, and then I'll type in my function. My function is minus 0.8 times x squared. Nope. 0.x squared plus 48x minus 280. So I've typed my function in there. I don't see it. That's not a problem. I'm going to go back to this page. I'm going to press variables. I'm going to use function 2, and I'm going to put in the value 30. So I put in the value 30. I'm going to pull that one up again. I'm going to put in the value 50. So I see my two values, 440 and 120. So this equals 440. And the profit when I make 50 cars is going to be less than that. What was it? 120. What's the difference in profit?
I can't do this quick math right now.
So when it goes from 30 cars to 50 cars, it's going to go from 440. Well, I want to write this the other way around because the original price is 30, isn't it? All right, so let me do P50, and then I'm going to take away P30, and I'm going to get 120 minus 440, which is equal to negative 280. So when I go from making 30 cars to making 50 cars, what happens to the profit? It goes down. I don't get a loss. I don't get a loss because I still make 120,000 here, but I was making 440,000. I was making 440, so I'm overproducing. That's why it's gone down. Because normally you would expect the more you make, the more you sell, unless you saturate the market.
So that's only 120 minus 440?
Yeah. So this minus 120, we need to turn that into words. What has happened here in terms of words? So profit goes down. Is that the best word? Decreases. So profit decreases by how much? No. This isn't 280. How much is it?
280,000.
Lorenzo. 280,000. What's the unit? Dollars. So typically with an interpretation, explain what it's doing and make sure you have some numbers in it as well. Some numbers and some units and a description of what is happening. Some numbers, some units and a description of what's happening. Let me just reread the question. Describe how their profit changes if they increase production from 30 cars per month up to 50 cars per month. Yep.
This is way easier than what I thought it was. It looks harder.
No, that's because I'm doing it. It always looks easy when I do it.
And then I'm gonna end up doing it, and it's not gonna be.
Yeah. All right. So this is the topic you struggled with. So this is another derivative topic. We've got tangent line question. And typically this type of question, we've also got a constant up here. This is what makes this one come at the end of the paper, is this constant there. And we've got a slightly harder function now. It's not a power function, it's a reciprocal function. So it gets a little bit tricky. First up, we have to find the derivative. So we have the function f of x is equal to x squared minus k over x. So your first step when you have a reciprocal or a radical function is to move it into exponent form. So we're going to rewrite this in exponent form. It gives us x squared minus k x to the minus 1. So in this form, we have a 1 there on the x that we don't normally show. And we want to move it up to the numerator. We just change it from being positive to negative. We change the sign.
I'm a bit confused how, never mind.
So we've done nothing so far, but what we need to do now is to find the derivative. I'll do that over here for saving space. So I'll use the implication symbol so I can move across the page. And that means that the derivative is going to be 2x plus kx minus 2. Might want to write that as f dash of x is equal to 2x plus k over x squared. There's the derivative. 3 marks. The equation of the tangent to the graph y equals f of x at x equals 2 is given. Write down the gradient of the tangent. So if there wasn't this k here in the function, we could just put minus 2 into there and it would give you the gradient of the tangent. But you can't. So in B, we have to extract the gradient of the tangent from this function here. So this function here is not in, what we want here is we want point slope form, which we can't really get, but so we can get slope intercept form. So let's rearrange this into slope intercept form. That will give us y is equal to, and what I'm going to do is I'm going to divide through by 2. Y is equal to minus 5 over 2 x plus 2. So I've got a 2 in front of my y. I've just divided through and then I've swapped the y-intercept and the gradient one and the x term so that it's in slope intercept form.
Minus 5 over.
Over 2. Sorry, when I write on this board, it's not as smooth as when I write on the regular one. I'm doing it straight into the PDF so I can save it and upload it for you.
Thank you.
So this implies, what is the gradient?
Minus 5 over 2.
Minus 5 over 2. I make sure that when I write my answer, it's clear on it. So I noticed it wasn't clear there, but as long as the answer is clear, I'm going to get my points. So B, what is the gradient of the tangent? We've got that now. So we can find the value of k. Remember I said we could find the slope from the derivative if that wasn't a k? So this question, you have to do it backwards. So when our x value is negative 2, we have this and we already know what the slope is. So in C, we want the gradient is minus 5 over 2. Here is our gradient. Our x value is negative 2 plus k over, and then we need negative 2 squared. At that point, we're going to end solve it. We put that into the calculator and end solve it. I won't do that on the board, I'll just do it in my head. That's going to be 6, isn't it? K is equal to 6. I reread the question, find the value of k. Yeah, I've done everything I need to do there.
Is that negative 2 to the power?
Yeah,
Okay.
yeah.
Can I ask you one question?
Yeah.
I'm a bit confused how the negative 5 was the number that became instead of k on B, like the beginning of gradient. How it became.
Okay, so
why was negative 5?
So we have this.
Yeah.
We have this. I'll do it over here. We have 2y equals 4 minus x. Sorry, 4 minus 5x. So this means that 2y equals, sorry, I'm not doing anything there. That means 2y equals minus 5x plus 4. So I just,
Yeah.
then I'm going to divide by 2. So if I divide by 2, I get minus 5x plus 4, and each one of these is divided by 2.
Oh, okay.
So then I get that negative 5 over 2 as my slope.
Okay.
That's my slope. So this is my slope. So I know that if I was to put the x coordinate, which is this one, minus 2, if I put the x coordinate into the derivative, it should give me the slope. It can't quite give me the slope because I have the k value. But if I put it in here, like I do on the right-hand side at this point, if I put it in here, it has to equal the same as the slope. And the slope is minus 5.2, so then end solve gives the same. Right, are we on to the last question? Yeah. Happy straw companies making straws. They're very happy people. Okay, we're missing a line on this one.
Which one?
Um,
Oh, I see what you mean, at the bottom.
Yeah, this one's missing a line. Let me just go and find in the Google Classroom. Is it here? Is it here? Yeah, we're missing this line here. The profit from the sales. Profit from the sale of 20,000 boxes just before we get to D.
That's why I
Let
not like I tried, but
me see. Will it give me a text box? Here. All right. So that line was missing from this version. Okay. So with a question like this, it's cleverly structured. So this is derivatives. It's an optimization problem. And the first thing you need to do is you need to find your function, you find your formula, and then you have to differentiate it. Now, with these longer questions, if they're very nice, like this one, if you get this one wrong or you can't do the first two and find the function, they give you the answer. So when they give you the answer in a question like this here at this point, it means you can still do C, D, and E without doing A and B. So don't give up and despair on these harder, longer questions. Sometimes watch for the question having a sort of break point in the middle of it and giving you the answer, which you can then use for the next part. Just 1 point makes all the difference. Calculate the surface area of the box. So we've got a bunch of rectangles here. This end one is going to be 12. This one here is going to be 8 times 3. So this space is 8 times 3, 24. And this top one is 8 times 4. So this top one is 8 times 4.
that is 32.
The purpose of this question here is to show you how to do it in numbers. Before you have, that's also helping here a little bit. So you're just doing the arithmetic with numbers. The only point in this is so you understand the algebra when you have to do it without numbers and letters. So it's very helpful here. So calculate the surface area of the box. We've got these three. This is 3 times 4. And we have 2 of each of these. So we have 2 of each of these. So we need to calculate the surface area. It's 3, 4, and 8. So the surface area is equal to 2 times 3 times 4 plus 2 times 3 times 8 plus 2 times 4 times 8. And then we just add all of that one up in our head, and it's going to be 136 centimeters cubed. There's our first one.
Is that like an equation?
We're using areas of rectangles. So if
Oh.
you look visually at each of these rectangles,
Yeah.
3 by 4, and then the 2's in that, I put the brackets in because each one of those brackets represents one of the rectangles at the faces, and the 2's, it's because there's 2 of every one.
There's 2 of each, right?
Yeah. Okay, next up we need to calculate the length of AG. So this question is drawn from multiple areas of the syllabus. So this is topic 3 of the syllabus, 3D geometry. And now we've got the distance formula in 3D. So we're asked to find the length of A from here to here. There's a few ways we can do it, but the easiest way is to use coordinate geometry. So if we were to, well, there's a bunch of ways we can do it, but I'm going to do it this way. If we were to take D as being the origin in 3D, like that, 0, 0, 0, then what is the coordinate of A? We've stayed along the x-axis and we've moved 4 along it. So the coordinate here is going to be 4, 0, 0.
Because 4.
I'm using coordinate geometry, and then I'm going to use the distance formula in 3D. That's the easiest way of doing it. I don't want to think this afternoon. I can use little right-angled triangles all the way through it, and I can just find it that way. There's another way to do it. So this is the easiest way for me today.
You took 3.
So the coordinate of C is we've moved along the y-axis by 8. That's the coordinate of C. So if we then move up to G, we've moved in the direction of the z-axis. So this is 0, 8, how high is it? 3. So I am going to use the formula sheet in 3D for the distance formula. Then on your formula sheet to page 6, right at the top, you see the formula. And we've got 8083, which remembers that. So that's A, I'm on B. So the distance, the length of line segment AG is equal to, and then using our distance formula, it's going to be quite easy. We've got 4 squared plus 8 squared plus 3 squared. Because the other ones are always 0, that one was very easy to do. In the distance form, you have to subtract the zeros, but we don't this time. And that will lead us to root 89. So this is equal to root 89. You can leave your answer in exact form, like this if you wish. They will accept this exact form. Or you can approximate it if you want to 9.43 centimeters. Okay, so that was that topic. C, find the number of, all right, let me read the bit. Each week, the happy company sells X boxes of straw. It is known that dPdx is equal to this. So where P is the weekly profits in dollars from the sale of X thousand boxes. So P is our profit function. That means dPdx is our marginal profit function, again. And we need to find the number of boxes that should be sold each week to maximize the profit. All right, so what we're going to do on this one, this is topic 5. This is unit 7 from the course. This is derivatives and optimization. So even though we've got a marginal profit function, we need to find, using this function, what value of X will maximize it. And the key thing about optimization, finding a maximum minimum. These are the keywords. The keyword that kicks you off on this one is find the number of boxes sold each week that will maximize profit. Maximum profit will occur when the derivative of the profit function is 0. Maximum profit, maximum and minimums occur when the derivative is equal to 0. We say it again because this is so crucial. When you're looking for a maximum or minimum and you're given the function, you find the derivative, set the derivative equal to 0, solve, and those X values will give you the maximum and minimum. Now in this question, we don't have to do those steps. They've already given you the derivative. So in this question on C, we're going straight to it. So I think is there another page after this for me to write on? Yeah. Let me jump to the next page. So for C, let's not squeeze it all in there. Where's the function? So for C, we want to take the derivative dp dx equal to 0. So when you're finding maximum and minimum, take the derivative, how it's expressed, put it next to 0, you'll probably get a point. Just if you haven't got a clue what you're doing and you see a function and you see the word maximum, if you can set the derivative next to a 0, you'll get your thing. So this gives us minus 2x plus 220 is
Ladies and gentlemen, this is a student bus announcement. May all bus users please.
Okay, so this is gonna, if we solve this one, it's gonna tell us that x is equal to 110. So we answer when we sell 110,000 boxes. And this is how many we should sell for the maximum. We need to find P of x. In D, we need to find P of x. We have a derivative to get us there. And we have a coordinate here. This coordinate is 20, 17. What is the profit in thousands? In dollars? 1,700. So there in that statement, it tells us a coordinate So the x values is the number of boxes. I think it was in thousands. So x is in thousands. So we just put in 20 for this one.
So I'm on bus, but thank you so much.
So what we want to do for this one is we want to find the integral
On Bruno.
minus 2x plus 220 dx, which will give us minus x squared plus 220x plus c. Putting in our y value and our x value, we can end solve for c is equal to minus 2300. And then we express our function that was requested, and that is that p of x is going to be minus x squared plus 220x minus 2300. So our last question now is E, find the least number of boxes that would be sold in order to make a profit. So if we look at our last question, find the least number of boxes that must be sold in order to make a profit. So this function basically has to be have a value of 0. So we found where this is equal to 0, it's going to lead us into the answer. So if we take p of x and aim to make 0 profit, that will give us the point this will occur. Solving that on the calculator, we're going to get 11.005 or so. So we remember that this is in thousands. So if we sell 11,005, we will make no profit. So reread the question. This is tricky on this one. Find the least value of boxes which must be sold each week in order to make a profit. We're selling boxes. Can you sell half a box?
No.
So the net value up from 11,005 is, yeah. So because the interpretation on the question is that this is an integer value that we're going to need from that function, then we have to have a whole box that this would be the answer. Okay, that is it for this exam. Thanks everybody. I'm just going to